What's happening? Welcome ninjas. Appreciate y'all tapping into the channel. Today's topic, we're going to talk about IP SLA. I feel it's very important if you're studying for any exam, or if you're just going to be working in the field. You got to get hands-on with the stuff. We'll just jump right over to the lab I got set up, and boom. So I'm using GNS3. If you guys aren't familiar with GNS3, it's just a lab simulator and everything, but basically we got 3 routers here. I've already set up all the routing and everything, pinged everywhere, and made sure all the basic labs connectivity is working. These are all our different networks that we got. The primary ISP link is using this 201, and 202 is going out the secondary, so try to keep that in mind. 200, this is simulating out there in the interwebs, you feel me? This is simulating the DNS server, and when I say it's simulating, these are loopbacks that are going to be on these routers. Command line, respective picture here, router 1's at the bottom, and then ISP1, ISP2. Like I said, this is going to be the 201, so this side should be 202 over here. I hope all that makes sense. See, 202 secondary, and again, I don't think I updated the descriptions on these, but let's see. ISP, maybe this one has it. I think I updated the description on one of these. ISP, right? ISP1 DNS server. This one should be ISP2 DNS server, but simulated web server over here. This is all ISP1 when you see that 20 ISP1, 201, 202. All right. So just pull up the lab, and this is just the lab that I got from old school work. So boom, you're gonna configure and verify the IP SLA feature. This is on exam topic network assurance section of the 350-401 Encore exam. This is an old lab, but it's still SLA, and SLA hasn't changed since I had this. This is a couple years ago, but SLA hasn't changed since I used this lab. But again, this is the same primary. I just mirrored everything to the IP addresses to all of that. Here they want us to just actually ping the simulated web server, the simulated DNS server at ISP1 and the simulated DNS server at ISP2, and we could do that as well, and then we can run a trace sourcing from the LAN of R1 to see which direction it's taken to get over to these destinations. So that's what we're going to do right now. So from R1, I already did it, 201.30. .30 is connectivity is good, and .30, if you remember, is simulating the DNS server, and this is simulating the web server. So we're gonna do a 200.254. That's all good. And then this guy, 202.158, is simulating the DNS server for him. 202.158. All right, and that takes care of that. Now we want to run traces to it. Let's see, how do we get to? Let's go over here to ISP2. So we're going to run a trace sourcing from here, and we're going to run a trace over to here. Let's see where it takes us. So trace route, and we'll just 209.165.202.158 source it from 192.168.1.1. And as you can see, he's hitting 201.1. So to get to this DNS server, this guy sources, or from the LAN, he come out here, hits here, and goes over here. So now we're going to hit this guy. We're going to run the trace and see which route he takes. So if we go back over, change this IP address to 201.130. Whoops, .130. 201.130. Let me run it again. I forgot what those mean, but we already know that the connectivity is good because we pinged it, but the trace route is definitely, the next hop is the 201.1. Not sure why it's giving me those codes right there on that response, but we're gonna keep it moving forward. That's something for me to learn again. Gotta always constantly be learning. So the next part of this, we noticed the trace route and everything, so they wanted us to keep that in mind. So we keep it moving. About halfway through this thing now, we're gonna start configuring IP SLA. So jump into R1 right here. Conf T IP SLA 11. Whoops. So I forgot with this. I don't know if you guys see this, and hopefully the audio is good. Sorry about my mic. I need to get one, guys. But this version, I looked up some white paper Once I find the link, I'll drop it in the description, but basically it's telling me that the syntax for this iOS version I'm using uses this, which is an older syntax. There's an even older one, which is RTR, which is before my time, so I guess I'm showing my age with that. So IP SLA Monitor, and then we could just question mark our way through this lab, right? 1 through however big that number is the number that we could use. So we're just going to use 11, and then it is the next thing here is type echo, protocol IP, and then I'm gonna put the destination. Again, it should look like this up here, but this is old syntax that I'm using because I'm limited by my iOS that I'm labbing up with. This is the only one image I could get my hand on, and this is what I gotta use. Frequency, like I said, how often do you want it to run? You can put it in X amount of seconds, 10 seconds, then we're gonna exit out of that, then we're gonna do IP SLA Monitor again, schedule your probe, the lifetime of it, forever, start time, when do you want it to run? Right now. So now we're just gonna go verify it. Show SLA config. This is to verify that it's been configured. My bad, you gotta put, I think it's monitor and the SLA number. Again, this is just syntax, so bear with me, guys. Monitor, config, and then the number right there. Just following along with this, these are the key elements that you should be looking at whenever you're going through that exam. This is where they're going to hit you. Target address, type of operation. So I say that to say you should be, right now in this video, you should be opening your mind and keying in onto these highlighted parts. Pause it, screenshot it, or whatever, and study this, because this is where, as far as the SLA section, you're going to try to use trick questions and all other kind of stuff. But this is a breakdown, so even in the real world, so you know what's going on when somebody needs you to look at an SLA configuration or an SLA probe or a SLA failure or anything to do with IP SLA. In my current role, I have to work with SLAs for different reasons. So right here we got it pulled up on our side, and it's all the same data, right? Entry number is 11. Type of operation, I got an echo operation going on. Target address, feel me? What else? Start time, I already passed. Life seconds is set for forever, right? Those were the kind of things they wanted us to see right there, right? Then we just move on down. So this command to verify the SLA that you just configured will give you the statistics of the probe and what it's doing. So let's look at that. Show IP SLA statistics. Keep forgetting to put that monitor, right? Do the old syntax. Alright, so last operation, return code. Again, they want us to look. Verify you looking at the right probe number, 11. Is it okay? Yes, it's okay. Number of successes. How many times have it succeeded running? 15. How many times has it failed? 0. Operation time, again, it's just reiterating that information of it being forever. Next, they want you to configure another probe. This probe is running over to the other simulated DNS server over here. So that's what we're going to do. We're going to configure another probe. So just more practice. They just getting you more practice, more hands-on. So if you labbing it up with me, you feel me? Let's lab it up. So let me bring back up my little cheat sheet, so to speak. Because I don't know the syntax off the top of my head, but after doing it a few times, it's just going to start. That's why I know type echo. You feel me? Then it's going to be protocol, IP, echo, whatever. And then different endpoint that they want me. 209.165.202.158. Got to put a frequency, how much I want that to run. Exit, schedule it. That's just the probe. Remember, we got to schedule to shoot this probe out there into the internet. SLA monitor, schedule. After I configure this, we're going to verify it the same way. And then we're going to test the SLA. Life, forever, start time, now. And again, show SLA monitor configuration 22. Let me just get into a routine, make it a habit. Entry number, operation, endpoint, bam, all that. Frequency, did it already start? And lifetime, right? What's the next thing we want to verify? Show IP, SLA, monitor, statistics. See, it didn't catch me that time, you feel me? Because I'm doing it more, you feel me? All right, so here it is. Again, habit 22. Is it running? Okay, it is okay. That's the return code. How many times has it succeeded? 4. How many times has it failed? 0. Operation lifetime forever. All right, moving down. We almost done. We almost out of here. I'm getting y'all out of here, but just bear with me now. Tracking options. This is how we gonna leverage SLA. So right now, remember, we got a default route. Remember when we were doing our traces, everything is going over to .1, 201.1. But now they're saying remove this, and they want us to create a floating static route. All that means is that you're going to add an administrative distance manually to your default route. This is a way that you can, when you add this to your default route, when we use these tracking features, we can now, depending on the conditions of the SLA, the static route can change. So, for example, once we have configured the tracking for the SLA that is pointing over here to the primary ISP link, if what this tracking statement is going to say is, hey, I want to track the reachability of this SLA, which its target is this endpoint right here. So it's making all the way through the router to this endpoint, right? That's what this statement is saying. This next part is delayed up. That's meaning to prevent any kind of flapping issues, because sometimes if this link is up and it's down, I don't want my SLA to fail every time it goes down. I want it to fail if it's down for a reasonable amount of time. And then with your customer, you're going to have baselines and everything in the real world, but for the lab purposes, the reasonable amount of time for it to be down is 10 seconds, and a reasonable amount of uptime for it is 1 second. So if I see it down longer than 10 seconds, then I'm going to consider that this SLA that this track is referencing is down completely. And if that's down, then that takes this static route out of it. But since I have a floating static route, meaning there's another route there with another administrative distance, that router is going to look in its routing table, and then it's going to replace that static route with the new route, which the new default floating static route, which will point out to this to still be able to get me over to here. Because remember, these guys know about each other, and they're using EIGRP for their dynamic routing protocol. I know that's a lot, but I hope all of that makes sense. Let's just get through it and configure it right now. So right now, they want us to get rid of this static route that we got right here. So we're going to start there. No. And then I'll just copy. Tired of typing. I'm lazy. So you copy, paste, right? No IP route. Now I'm going to add it back. Well, let me see. But this time with the AD of 5. Then also, next step after that, scroll back up, is to add the tracking statement. So track SLA monitor. Oh, again, different syntax than this guy. Track 1, IP SLA. Oh, sorry, it's RTR again. R11 reachability. So disregard that. That's just syntax. And then I'm gonna put delay 10 seconds. Oh, sorry, delay down 10 up 1. Exit out of that. So scroll down a little bit more. So now let's see where we at. Do show run section IP. Oh, show run section IP route, right? Track. So now I got the track set up. Now all I have to do is configure the static route with a higher AD than the first default route that I got, because this route right here is more important to me because it is looking at connectivity, not just to 201.1. It's looking past that. It's looking at connectivity to 201.30. So that's more important to me, right? And then this is second most important to me because it's looking at my backup, my secondary link out to the internet, right? So, which is hitting this guy over here. That's how I know I'm getting all the way beyond just my ISP link. I'm over here in this network for this router. All right, so pull that back up, and I'm gonna put this static route in here with the AD of 2. So IP route, oh, configure it, IP route 0.0.0.0.209.165.201.1 to track 1. Now, if I put a debug IP routing, oh, we missed it. I was supposed to put the IP routing debug before that so that you guys could see that it flushed out the AD of 5 and replaced it with the AD of 2, but that's okay because we're gonna see it on the next one because I'm gonna configure another static route down here. We'll see it on, we'll catch it on this one, right here. First, let me configure the track actually. Track 2, this is for the secondary link, IP SLA monitor. Oh no, remember RTR, sorry, RTR 22. I want to track the reachability of that SLA 22. Delay down 10, up 1, same parameters for that. Then you exit out of that. Now I'm going to configure the default route I want to track this on, right? Start at 0, and this one is going to 201, 209, 165, 202.158. 3, track 2, and 3 is my AD. I think I put one too many zeros. I'm getting hungry, y'all. My bad. Alright, so what they want to point out here is if we look at the default route in the routing table, the static default route remains this guy even though we dropped another default route in there because the AD is higher. Alright, so we're on page 9 of 13, so I'm going to just scroll up real quick. What have we done so far? The objectives, we've configured and verified that. We knocked that out. And we're about to test the IP SLA feature now. And we verified, we haven't used debug command to verify it, but we verified the configuration operation using the show command so far. So let's go back down to page 10 right here. So we're on the last step of verifying the IP SLA operation. Let's read through this one a little bit. In this step, you observe and verify the dynamic operation routing changes when track objects fail. So basically, we're going to force one of those track objects. We tracking remember the track objects reference in this lab specifically reference SLAs, which are probes that we have going to our respective destinations that are on our simulated internet. 201.30. I could have ran it out here to this internet. I got a server, web server simulated sitting out there, but we're just running it out here and simulating it. That's the web, right? And then we're going to observe what happens with debugs. Then we're going to verify all the static route entries in the routing table. Then we'll re-enable the loopback. So to simulate this, this is on a loopback interface. So we're going to log into that and shut that down. And let's see what happens down here. The magic gonna happen down here. So we're gonna clear this screen. Interface LO1. Gotta go in config mode first. LO1. Shut that bit. Boom. Remember, we gotta wait 10 seconds. It ain't gonna do nothing right now. The SLA is just keep hitting it. It just keep probing that IP address over there, right? The 201.130. We gotta wait for 10 seconds. We're almost up out of here. Look what happened. Bam. That bit undropped. So stop the debugging and just let's take a quick peek at these debugs and see what happened. Debug message. This looked like a log message actually. This is a log message. Tracking, notification, levels. You're gonna have to know your levels in these syslog levels. Number 5, right? Every alley cat eats watery noodles. You know what I'm saying? That's that mnemonic for it. But I forgot the rest of it. Every alley cat eats watery noodles in dumpsters or something like that. But look it up. Google that thing. That's in the mnemonic to help you remember these different levels. But anyways, I'm getting off subject. Track 1, SLA 11, reachability went from up to down. Delete that IP route that we had with that metric of 2. Add the one with the metric of 5, right? So let's see what this thing said. Whoops, scroll down. Oh, it was supposed to add the other one. So look, let me see what we got going on. This is good for me to see. I thought it was gonna work, but it didn't. So let me see, show IP route scan gate. Yeah, it's got that guy in there. I don't know why it's got him in there. Let's see if we could figure that out, why he's got that in there. He should prefer the of the other one. This guy. Let's see if he takes the same way. 209.165.201.130. Still taking the same way out. That interface loopback 1 is shut. Let me check my config. Let me run through that again. Alright, let me no shut it. Try it again. So it came back up. Let's see. Let me check out this route. 202.129. I don't think I put that for my route. Maybe I did. Oh, that's the problem. 202.158 should be 202.129. And see, that's why it's good to do the, sorry about this, guys. But we were able to work through it, find out what we did, but that was me just going through fast, and that's good to know. When you're on the test, you don't want to go too fast. So 202.158, right? 3, track 2, track 2. Then we're going to just drop it in there again. It is going to be track 2. We're going to do this. Whoops. Boom. Change this to 129.29. Alright, now we verify that again. Right here. Alright, so we're going to turn debugging back on and shut it back down. Again. Shut it. And now watch the magic happen. This is what it was supposed to be like. You feel me? But I'm glad y'all held it down with me. Appreciate that. Just gotta wait these 10 seconds. Just so y'all can see this failover happen. So it's down. And then there we go. That's what we wanted to see, right? So now we know what we're looking for. Boom. Same notification up to down. Delete this one. Floating static. This one can float. That bit could float right up. The one that we have for 3. I'm sorry, with AD of 3, and now you can see it here, and we're also pointing to our secondary ISP link 1.129. Now we're going out there, and we could even verify that with a trace, right? So let's stop the debugging and then do a trace. And then we do it already, trace route, and now you see he's hitting 202.129 to get over to that 201.130. So now traffic's flowing out this way because the SLA kicked all of that off, right? So that's all they wanted to show us on that part. And then of course the reverse of that is when the link comes back up to verify those SLA operations. Also, this is a good way to see when it's broke, how it looks. So look at the stats, right? Show IP SLA monitor. This is part of verification, so it's good to take notes on this, how it looks. You got your 2 probes. Look at probe 22. Everything's okay. Successes, number of failures is 2 forever, but that's okay. It could fail. Remember, can't fail longer than 10 seconds though. That's the delay condition we put in there. This one timed out. That's not good. No connection. Busy timeout. What probe is it? 11. Lifetime forever. Oh, I'm sorry. Success is 113. 39 number of failures. This is going to, every 10 seconds, it's just going to keep on failing. So this number should increment. This number should not increment. See, it's not incrementing. Was just 39. Now we know which probe to focus on and how to troubleshoot that. Also, we're going to turn the debug back on down here. Debug IP routing. No shut this. I believe that's what they're doing while we wait for this. It already came up. We just had to wait for that probe to run. It only has to be up for 1 second, remember? And then we can verify the same stuff. Right, all the same things to verify we're back on track. Show IP route. Again, what's the static default route? We're back to the AD of 2. We're back to going out our primary ISP link because that reachability is up with that SLA. Let's look at our SLA statistics on that probe. 45 failures. That's okay now because we got a return code of, feel me, on our probe. So successes should start incrementing. And failure should stop. So let's see. Let's keep running this till we see them. It looks like it already did. Successes are incrementing. And those were the only things right there to verify. And then of course the debug when everything came up, tracking down to up. Get that floating static route. Now I hope you see why they're calling a floating static route, because these static routes are floating in and out of the routing table. Because we have them here. We have them here. That's in our config. We got default static routes. We got 3 of them, right? But when you add these different ADs on them, that's when they can come into play, right? So this one's winning right now because this track is up. Because this is a part of the reason why that has to work. If this didn't have a track, this guy would win, right? This guy would win because this one is only working because of that track. But the main part of this was just verifying we did those 3 things. We scroll back up to the objectives, right? We configured and verified the SLA feature, then we tested the IP SLA feature, and we verified the config and operation using show and debug commands. So we did all of that. If y'all are feeling this video, I appreciate it, man. As always, please like, comment, subscribe, share the video. You feel me? Let them know Network Ninja. Holla at your boy. Holla at me, man. And y'all already know what time it is. The boy finna get out of here, so always say ninja. Anish.